This is topic 11-2, graphing inequalities in two variables, day 2. Our objective for today is I can graph inequalities with two variables. What you'll notice though is that the equations that we're dealing with today are in standard form. So our essential question is going to be, how can I graph inequalities with two variables in standard form? So how can I graph inequalities with two variables in standard form? So our buildwork problem today deals with an equation in standard form. Notice it's an equation, not an inequality. So we're going to review how to graph equations in standard form and then go on to graphing inequalities in standard form. Standard form means we have the x and the y on the same side. Our goal is to get an equation with y by itself. So we're going to write y equals blank x plus blank, and we are going to box in the variable with the coefficient in front of it. So the coefficient is -2. Let's go through our steps. Our 10 is already on the right side of the equal sign, so it drops down into the blank at the very end. We have 3x on the left, so we're going to subtract 3x. That means the number in front of the x is a -3. And then last, we have a -2 inside the box. So to get rid of it, we're going to divide both sides by -2. That means everything gets divided by -2. Our equation then, once we simplify, is y equals a positive 3/2, positive 3 over 2x minus 5, because 10 divided by -2 is -5. So my equation down below, I'm going to rewrite it, 3 over 2x minus 5. This means our slope is the number in front of the x is 3 over 2, and our y-intercept is -5, or the point 0, -5. So to graph, we're going to start at our beginning point, or our y-intercept at 0, -5. And then we're going to move using the slope to get our other points. This is a positive slope, so the top number tells us how far to go up, bottom number tells us how far to go to the right. So we're going to go up 3, to the right 2, we get another point. Up 3, to the right 2, we have another point. Up 3, to the right 2, and we're going to continue this pattern until we fill in all the points that we can. Up 3, to the right 2. Going back to our beginning, we'll do the opposite, down 3 to the left 2 in order to get what the other side looks like. Then we'll draw our line connecting those dots, and we have now graphed an equation that was originally in standard form. These were going to be the answers to our assignment. Let me skip that. Okay, so to graph equations of inequality, to graph inequalities, we have to know what's going to go on when we multiply and divide by a negative number. So let's talk about what happens when I'm given an inequality where 6 is less than 12, and that is a true statement. 6 is less than 12. But what happens when you multiply each side by -2? So I'm going to multiply the left side by -2, and I'll multiply the right side by -2. Remember, as long as I do the same thing to both sides, I should stay equivalent. -2 times 6 is -12. Less than -2 times 12 is a -24. Well, now we have a false statement because -12 is not less than -24. If I look on the number line, start where my 0 is, going negative, I will see -24 is actually the smaller number. So this is false because -12 is greater than -24. It's closer to 0. So what I should have is -12 greater than -24. Notice that's not what I have, what we ended up with. So let's try 6 less than 12 again. And now we're going to divide each side by -2. This will give us -3. And again, we have a false statement. Negative 3 is not less than, and that should be a negative 6. Because 12 divided by negative 2 is a negative 6. That is false. Again, if I look on the number line, here's my 0, I will get to negative 3 and then negative 6. So this is false because negative 3 is greater than or bigger than negative 6. So what I should have is, it should be, and I'm putting my text talk S/B, negative 3 greater than negative 6. So our next question asks, well, if I multiply or divide by a negative number, is my inequality still true? And what we've just seen is that no, our inequality becomes false. So if you multiply or divide each side by a negative number, is the inequality still true? So our inequality becomes false. So our next question is, how can I make it true? We can make it true by switching the inequality. So our conclusion is, when we multiply or divide by a negative number, you should switch the inequality symbol. Okay, again, when we multiply or divide, let me add here, both sides by a negative number, you should switch the inequality symbol. And that will keep the statement true. So let's do that now. The main thing we're going to look at is, what is the number in front of the y? Because if the number in front of the y is negative, that means we're going to be multiplying or dividing by a negative number. If the number in front of the y is positive, we do not have to switch. What we do have to do in order to graph is we do have to solve for y. So we're going to do the same thing we did before. Put a line where the inequality is now. We're going to put y blank x plus blank, and then box in the number with the variable y. Notice that this is a positive 2. So now take the 6, we'll drop it down. The 3, we're going to subtract 3 from both sides, or 3x, so the 3 now becomes a negative 3 that goes in front of the x. And now we are dividing by a positive 2. Notice, since we are dividing by a positive number, our inequality does not change. So our inequality is still going to be y is greater than. Our equation then ends up y is greater than negative 3 halves x, and then 6 divided by 2 is 3. From our equation, we see that the slope is negative 3 over 2, and our y-intercept is 3, or 0, 3. We also see, because it's an inequality, that it is a dashed line, because it doesn't have a line underneath it. And since it's greater than, we will shade above. Since it's an inequality, we will have shading going on. So start off with our y-intercept at 0, 3. Here's our point. And now let's move with the slope. The top number, since it's negative, goes down. Bottom number's to the right. So we go down 3, to the right 2, down 3, to the right 2, down 3, to the right 2, down 3, to the right 2. Starting back at our beginning point, we can go up 3, to the left 2, and up 3, to the left 2. Since our slope is negative, I should have a decreasing line. Decreasing. And it's dashed, so let's put some dashes. And yes, it is decreasing, going downward. The shade above, let's start at the y-intercept. I'll start at my y-intercept. I want everything above it. We have completed our graphing of the inequality. Let's do example 2. We want to, again, solve for y, so we'll put our line down the inequality sign. We'll have a y blank x plus blank. There's an extra letter here on the end with that's -6. Let's cross it out. It doesn't belong. Box in the number with the variable y. That is a -3 this time. So the -6 will drop down to the box all on its own, or just the line on its own. There's a number 1 in front of the x. It will cross the line, change the sign, so it becomes a -1 because we're subtracting 1x from both sides. Now we're going to divide by a negative number. Since we are dividing by a negative number, this means we will switch the inequality. Switching the inequality, it used to be greater than or equal to, it now becomes less than or equal to. Or divide by -3. So again, because the number in the denominator is negative, we're dividing by a negative number, we must switch the inequality. Simplify, we get y equals less than or equal to a positive 1/3, because -1 divided by -3 is a positive 1/3, and then -6 divided by -3 is a positive 2. Our slope is 1/3, our y-intercept is 2, or 0, 2. It's an inequality. It has a line underneath the less than sign, so that means it is a solid line. And because it's less than, we shall shade below. Start with the y-intercept at 0, 2. Slope tells us how to move the point. We're going up 1 to the right 3. So up 1 to the right 3, up 1 to the right 3, up 1 to the right 3. Do the opposite from the beginning to get the other side. So down 1 to the left 3, down 1 to the left 3, down 1 to the left 3. We'll connect with a solid line. Notice that line is increasing, which our slope tells us it should be. Now to do the shading, start at the y-intercept, and we want to shade below because it's a less than, so less than that point. Example 3, want to solve again. Draw a line, box in the variable, get the y, blank x plus blank. The 9 will drop down to the last line. 4x, we're going to subtract 4x, so the number in front of the x is now -4. Positive 3 is in the box. We're going to divide by 3, so everything's divided by 3. Notice we're dividing by a positive number, so our inequality doesn't switch. We started off with less than, we're going to end with a less than. So we get y equals, or sorry, y is less than -4/3 x, and then 9 divided by 3 is 3. Our slope is a -4/3. Our y-intercept is 3. This is an inequality. It's less than. There's no equal to, so just say dashed line. And because it's less than, we shade below. Start off at our y-intercept of 0, 3. It's a negative slope, so we're going to go down 4 to the right 3. So down 4, 1, 2, 3, 4 to the right 3. 1, 2, 3. Here's my new point. Down 4, 1, 2, 3, 4 to the right 3. 1, 2, 3. Another point. Down 4, 1, 2, 3, 4 to the left 3. 1, 2, 3. Another point. Up 4, 1, 2, 3, 4 to the left 3. 1, 2, 3. We're going on the other side. It's a dashed line, so we would draw a dashed line to connect the dots. To do the shading, start out the y-intercept. We are less than, so we're shading below that point. So everything below. When you're making your shading, please do it lightly. Enough to see that it's changed, but not too dark. Number 4, let's do it again. Draw a line, box in our number with the variable y. Notice what's number with the y? It's a -1. So automatically I'm going to know I'm going to do some switching because I should be dividing by a negative number. Start off the same way. Y blank x plus blank on the other side of the line. 5 drops down. The number in front of the x is a -1, so to cross the line we change the sign, becomes a +1. And then we're going to divide by a -1. Again, because I divided by a negative number, that means we are going to switch the inequality. It was originally less than, and now becomes greater than and equal to. So our equation, y greater than or equal to 1 divided by -1 is a -1, x, and then 5 divided by -1 is -5. Our slope is -1. I'm going to write it over 1 so I know how it moves. And our y-intercept is -5. That's our beginning point of 0, -5. This is an inequality. It has a line underneath, so we have a solid line. And then because it is greater than, that tells us we shade above. Starting with our y-intercept, 0, -5. Our slope is -1 over 1, so that tells us go down 1 to the right 1, down and to the right. And we do have a decreasing pattern. We go up 1 to the left 1 to get our other points. It's a solid line, so let's connect our dots with a solid line. Our shading is above, so start with the y-intercept, and we're going to go above. Our last problem deals with determining whether or not we have a solution. So we start off the same way as solving for y. We draw a line, box in the number with the variable, that's a -1. We got y blank x plus blank. We have a -2, it drops down to the last number, last line. A 3x, so cross the line, change the sign, becomes a -3x because we will be subtracting 3x from both sides. And then notice we will be dividing by a negative number. If we divide by a negative number, we have to switch the inequality. Our inequality started off as greater than. We are going to now change it to less than, pointing in the other direction. So our final inequality is y is less than positive 3x plus 2. Our slope is 3 over 1, and our y-intercept is 2. Going to notice it's a inequality, and it doesn't have an equal sign, so it's a dashed line. It is less than, so that means we are going to shade below. Starting off at 0, 2. Using our slope, we'll move up 3 to the right 1, up 3 to the right 1, and then down 3 from the beginning to the left 1 in order to complete the other side. Down 3 to the left 1, down 3 to the left 1. It is important you go throughout the entire graph. We'll draw our dashed line through our points. And then our shading, start at the y-intercept, and it's shading below, so we'll go below. Second part of this question is which one of the points would be a solution? To be a solution, that means it will make a true statement if I plug in the numbers. Another way to look at it, though, is to look at the graph itself. A solution would be any point that is in the shaded area. Notice that our inequality is less than, it doesn't say equal to, so it must be below that line in the shaded area. So we're going to plot the points to see if they fall in the shaded area. If they fall in the shaded area, they are solutions. If it doesn't fall in the shaded area, it is not a solution. So we'll start with -2, 0. Our x is -2, our y is 0. Our point, notice it is outside the shaded area. It is not a solution. 4, 8. We'll go to 4 to the right, 1, 2, 3, 4, and 8 up, 1, 2, 3, 4, 5, 6, 7, 8. And notice this point is in the shaded area, therefore it is a solution. Negative 6, negative 2, negative 6, and negative 2. This is in the third quadrant. It is not in the shaded area. Positive 8, positive 3, so positive 8, positive 3. It is in the shaded area. It is a solution. And then 1, 5. This is probably the most tricky one. I go 1 to the right and up 5. 1, 2, 3, 4, 5. You'll notice that that is the point that is on the line. Because our line is a dashed line, that means it is not included, because we just want things that are less than, not equal to. So 1, 5 is not a solution because it is on the line, and our inequality says it should not be equal to. So to answer our question, how do I graph equations? How do I graph inequalities with two variables that are in standard form? We must solve the inequality for y. And if you multiply or divide by a negative number, you must switch the signs. I'm sorry, switch the inequality. This concludes topic 11-2.